Hello everyone and welcome back to the channel. Today we're going to take a look at an ATX computer power supply that tries to switch on and switches off, or power cycles, or even boots, but as soon as you draw some power from the CPU, the computer shuts down. At this point I want to do a disclaimer. Working with mains voltage is dangerous and can be lethal, so this video is for educational purpose only. Now, this is an old 500 watt power supply that has tons, as you can see, of fan connectors, Sata connectors, even dual 8-pin PCIe connectors that you can use on many modern VGA cards. This one has been operating 24/7 for many years, so we definitely suspect the electrolytic capacitors may have gone bad. Let's take a look first of all at the symptoms, and we will take it from there. At this point I have connected a power cable to the power supply. It is connected to a socket that has a switch, so I will open it from there. The switch here is at on position, and let's fire it up. So now power is supplied to the ATX power supply, but in order to start a computer power supply we need to bridge the green wire with a ground. Any ground will be fine, so let's do just that. Take a small wire. I think this is going to be fine. And let's try to start our power supply. And as you can see, check at the fan. So fan spins a bit and then stops. Actually at some point it was switching on, but as soon as you try to pull some power it would switch off. Let's try one more time. Jumper to the green and nothing. So at this point I had the multimeter here to take some measurements of the voltage, but that won't be possible at this moment. Switch off the power. Now I'm going to leave this for 5-10 minutes to get the capacitors a bit discharged and disassemble the power supply. Now let's start disassembling the power supply. As most of the power supplies, you remove the top 4 screws here, and no, I haven't shown. So these are the characteristics, the specifications of the power supply. It has a very good twin 12 volt rail. Now remove the top cover and put it on the side. And straight away I can see some bulged and leaking capacitors, you know, here, in there. So as we suspected, a computer that is constantly on will damage at some point the electrolytic capacitors, and they will need to be replaced. Everything here is soldered onto the power supply, including the mains power cables here. So I can see one screw there, one there. Let's start from that. I cannot stress enough how careful we need to be, as if the capacitor is not discharged, we may touch, when removing the PCB, we may touch the case, and we will definitely get a good shot from that. One screw there. I can see we do have some side screws on the heatsink, so they are using the case as a heatsink as well. They have put a bit of a heatsink grease there. Are there any other screws here that may stop us? So I will need to remove this plastic clip here, so that I can take all the cables out. I think if we twist this, it should release. I don't know. Yeah, there we go. That's our clip. So now we can slide the cables out. Also, those were all the screws. And there we go. I will fire up the soldering iron to remove the two power line cables there, to give us a bit of comfort to work on the PCB. Let's try to disconnect those two cables, and they went in the effort and put some elastic there as well to help it with vibrations, etc. So one there, and the other one, there we go. I can see a plug here that we could remove and release our fan, but I don't know. I think I will try to desolder the capacitors with this on. This does look quite decent, actually, as far as quality goes. Let's fire up the desoldering iron and start removing some capacitors. So as the desoldering station heats up, I want to stress at this point that in many cases that the power supply is not able to start and the hiccups spins the fan for a bit and stops, we should always check the capacitor of the PWM power IC, and in many cases if that capacitor goes bad, the whole power supply won't be able to start. In this case, the signs of bad capacitors are obvious, so the best practice is actually to replace all the electrolytics in this power supply if we don't want to visit it again. The desoldering station is hot. Let's start with these three ones. They have bented the pins legs of the capacitors, which makes it a bit more difficult, but we should be okay. We want to use definitely some flux in all the places we are going to remove capacitors. Okay, let's go with that one. That is better. And the third one, which is here. Okay, and the other piece is there. So those three are out. We see that they are connected to the ORATS cable, which indicates that it is the 3.3 rail. Out of the three, two are bulging on the top and one has also released some electrolyte there. Let's take a measurement. Oh, this one is good actually. Second one. Look at that. Not only it is at 1/10 of its capacity, it has an ESR of 4.1 ohms, and this is a low, of course, a low ESR capacitor. And the last one, Oops. And the last one, there we go. This one that has leaked is even better from the other one, of course at half its capacity and quite high ESR. Now let's remove those two. They don't look damaged at all. So these are 470 16-volt jobbies. This ATX power supply does use some very strange in size capacitors. They are very thin. So these are absolutely fine, no problems there. And let's see, we have a few more here, here and there. I want to take out this one that is closest to the heatsink, as this of course creates heat stress to the capacitor. It should be these two. I'm checking that both pins are free. It is glued to the coil there. Yeah. I think that will do it. They have put some heat shrink there, and this is a 220 2200 6.3 microfarads, same as the first ones we removed. Let's test this one as well. There you go. Definitely bad one. Let's continue. We do have a couple there, and we see a bit of heat stress on the PCB as well. Sometimes it's not that easy to recognize the capacitor legs there. Okay, I have broken this elastic connection here. And this is the one that we freed. Will it drop on its own? No. Let's remove the one on the side there, and maybe we can take both of them out. Let's give it a wiggle, and sure enough, yeah, that is the other one as well. One 16-volt Joby. Definitely a bad one. And the one next to it, and the one with the heat shrink was exactly the same. Oh, actually not. So the one is the CapXon, and the other one is a Teapo. That's very interesting. Same size and capacity. Let's take a look at this one. Yeah, this is a good capacitor. So we have one last one there, and 1, 2, 3, 4 here. Oops. This is the one. Use a bit of flux. Same one here. Good one as well. It didn't have any signs of problems. Now let's go to these smaller ones. Some signs of heat stress here as well. I cannot make out. So this is next to the IC. Okay, it should be this one. I can see here that one diode was broken or broke now that I touched it with the soldering iron. This is a 22 microfarad. Wow! This must be the second time I see an FR Panasonic capacitor in a consumer product. Very curious to see if that is okay. And of course, look at that. 0 ESR, 25 microfarads. This is a perfectly fine capacitor. Now we have this one. Should be here. Wow, another Panasonic VZ series. Sorry, this is an Ichicon VZ series 100 microfarad, 35 volts. This is almost good. It's not, if I remember correctly, a low ESR capacitor. This is a standard capacitor. We should replace it anyway, but this is what it measures. Oops. Those two, and we are done. Oh, I have removed the small one. Let's remove the big one. And it will be easier to remove the small one as well. A Hitano 2200 10-volt Joby. Let's see how it performs. Absolutely fine. This is a known brand actually, not as good as the Nichicon, Chemicon or Panasonic or Sanyo, but it is a quite well known brand. Let's take the small one here. This one is 2.2, 100 volt. And it is absolutely fine. All the capacitors are out. I will take a look at this IC to check if that was a small signaling diode. Find the replacement capacitors and start soldering. We are back with all our replacement parts here. You can see the size difference between these two, so it will be a bit difficult to put back the capacitors, but it will be a tight fit, but we will manage it, I think. So let's start our soldering iron and start right here where we had the three CapXon ones. At this point I want to say that interestingly enough, I want to replace some of the electrolytics that are good and of a known brand. I will replace though all the CapXon ones, of course, also those two that measure good, and it's just an experiment to see how long it will last. Of course, we should take care of the polarity of the capacitor. R minus is marked there with the lined indicator, and let's try to put our three capacitors back in there. I will remove some elastic here just to create a bit more space, So always be careful about the polarity. Here is my first one. It will definitely not go all the way in, as the pins are a bit wider. Oh, and the last one is in my hand. So there we go. This is the best I can do. It should be just fine. If you remember, the PCB doesn't fill all the case, so we should be able, even if these are protruding a bit. I should use the smaller tip for this job. Now for these two 470 ones, the closest I have were 35 volts instead of 16. These ones should be fine. Now another 6.3 here. So there is a coil there that doesn't let us to go much more inside, but I will put it just like that. We should be good to go. Well, that one is going to be a tough one. So that was the one they had a bit of heatsink around the capacitor, and I'm thinking of doing the same thing. Actually, I won't put anything because it will make the diameter even bigger, so it wouldn't fit easily there. It's already a bit tight. Nope. Not using the same size can be a problem, as you can see, but those are very odd sized capacitors. And there we go. It will touch a bit hardly the heatsink, but there is not much we can do there. So a few more to go. Same thing here, because the capacitors I have are slightly bigger. I will use where is it, the Teapo 1000 microfarad, which is a 4000 hour long life capacitor. Now I will have to fit the other one in here, which is a bit of a nightmare actually. There we go. Now let's try to put the other one again. Oh no.
A few years later. And I think that was all. Now there is one last thing, and that is the diode I broke there. I think I will go with a small signal 1N1448 4148, whatever it is. See if that will work out. Now about the diode situation, I'm looking at the schematic, the application diagram for this IC and another example. I found that
These two diodes serve as the UF 4004, which is shown at this schematic here, and this one indeed is a series with the one I broke, so I'm going to use the 48148 diode. Hopefully it should be just fine, and we will find out, of course, if it's not. Apply a bit of flux there. Our cathode was here. Nope. And the other piece here. I will add a bit of solder here. I don't know if these should be connected or not. Take a look there. Yes, they are. So apply it again, just a bit of solder to the both of them. There we go. And this should take care of the components that we needed to replace. Next thing is that to give this a bit of a cleanup. So here is the bottom part of our case. We will need to solder these cables back. Soldering iron is hot. Just to get everything aligned. And one more. Where was it? Just the one screw there. Now let's apply power. So here is the switch on. And 3, 2, oops, 3, 2, 1. So nothing is smoking there. That is a good sign. And let's take a look if we get any measurements at all. So with the green wire, .2 volts. Do we have on the blue? No, I don't remember. The purple, 5 standby, that is good as well. And nothing there. Now, moment of truth. Let's try to power up the power supply. As we said, green with and yes, it is switched on. Let's take our measurements. 3.3 volt rail, a bit high really. Oh, I switched it off. My wire is not very secure there. 5 volt, 5.3. Remember that all this is unloaded, which won't be the case in a computer. And let me pick here to see the 12 volt rail. Oops, not this one. Something like this one. And sure enough, we do have our 12 volts there. I will switch it off and try to put some load on it. Actually, I want to try to oil the fan because it is vibrating a bit. There we go. Although, as you can see, it does move freely. Oh, so this is a ball bearing fan. Nice one, but we won't be able to oil that. So in we go again. If we can pull some current. I have the cable sorted, so as soon as I apply power, the power supply will switch on. And as soon as we put some load there, we get the 3.3. Don't look there because we have our current lost due to the cables. A bit low with just 0.7 amps. That really doesn't look that good at all. But many times, if the other rail, for example the 5 volt one, is not loaded, we get that imbalance. Let's apply some load on the 5 volt rail and see. I mean, that doesn't look very safe. I have a 10 ohm 10 watt resistor on the 3.3 rail, and the electronic load and the multimeter on the 5 volt rail. Let's start it. Oh, I am missing my jumper cable. So back, everything is there with the cable. Let's try to start it. Now we get much better regulation. Let's apply some load. It looks decent. That will be all for today, folks. Let me know in the comments below, was it worth it repairing something like that? It did take some time and some components as well. Let me know in the comments if the 4148 was a good choice for the broken diode there in the PWM IC. Please hit the like button if you enjoyed this video, and consider subscribing if you enjoyed this content. Thank you so much. See you in the next one. Bye.